1, amines. So the chief commercial use of amines is as intermediates in the synthesis of medicines and fibers. So most of the organic compounds உடைய majority usesல மெடிக்கல் ஃபீல்டு அப்படின்றது ஒரு மெடிக்கல் ஃபீல்டோட யூஸ் அப்படின்றது ரொம்ப ரொம்ப அதிகமாக இருக்கும். அண்ட் சிமிலர்லி இன் அமைன்ஸ் ஆஸ் வெல் வி ஆர் ஹேவிங் த சிந்தசிஸ் ஆஃப் லைக் medicines will have majority proportion or if usage of amines, and we will see a lot of compounds related to nitrogen that's present in a lot of medicines in the upcoming chapters as well. So first of all, let's see the objectives. So after studying this unit, we will be able to describe amines as derivatives of ammonia having a pyramidal structure. So they have initially stated that it's going to have a pyramidal structure and it is a derivative of ammonia. So ammonia is NH3. Then classify amines as primary, secondary and tertiary, UPAC naming and common naming nomenclatures. And then describe the some methods of preparation, properties, distinguish between primary, secondary and tertiary. Describe the methods of preparation of diazonium salts and their importance in the synthesis of series of aromatic compounds in azodides. So that's what we are going to have in this particular chapter. So the same set of sequences we are going to follow in this particular chapter as well. So first, amines. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms of a ammonia molecule by alkyl or aryl groups. So amines na enadhu? It's an important class of organic compounds derived by replacing one or more than one hydrogens from the ammonia by an alkyl or an aryl group. So in nature they occur among proteins. So the occurrence is more important as well. So they occur among proteins, vitamins, alkaloids and hormones. So proteins, obviously amino acids constitute the proteins and certain vitamins, and a lot of hormones are also influenced by the presence of amines, that is nitrogen containing compounds. Synthetic examples includes, so இதெல்லாமே வந்து naturally occurring சில முக்கியமான amine derivatives, அதாவது nitrogen containing compounds. And synthetic examples என்னன்னா polymers, obviously certain dyestuffs, and then we have certain drugs. So these are all like certain compounds of nitrogen and its their derivatives. So two biologically active compounds, namely adrenaline and epinephrine. So சில biological compounds பற்றியும் இங்கே ஒரு நோட் கொடுத்துருக்காங்க. Both containing secondary amino group are used to increase the blood pressure. So இந்த adrenaline அப்படின்றது obviously it is used to increase the blood pressure, so we can just mark it out. So novocaine, so there is another example over here. Novocaine, it's a synthetic amino compound. Adrenaline and epinephrine are secondary amino groups which are occurring naturally. So there is a novocaine, that is a synthetic amino compound used as an anesthetic in dentistry. Anesthetic in dentistry. Okay, fine. And then we have Benadryl. Benadryl, a well-known antihistaminic histaminic drug, also contains tertiary amino group. So there is something called as Benadryl, which is a tertiary amino group. It is an antihistaminic drug. So novocaine is an anesthetic and this guy is an antihistamine. Quaternary ammonium salts are used as surfactants. So they are also used as surfactants sometimes. Diazonium salts are intermediates in the preparation of variety of aromatic compounds including dyes. ஸோ சில முக்கியமான டை ஃபார்மேஷன் அப்படின்றதுல இந்த டையசோனியம் சால்ட்டோடைய பங்குன்றது ரொம்ப ரொம்ப அதிகமாக இருக்கும். கண்டிப்பாக அது ஒரு இன்டர்மீடியேட்டாக இருக்கும். ஸோ in this unit you will learn about amines and diazonium salt. So first of all we will enter with amines. Amines can be considered as a derivative of ammonia obtained by replacement of one or two or all the three hydrogen atoms by alkyl or aryl groups. ஸோ ஒரு ஜெனரிக்கான காமனான ஒரு டைப் ஆஃப் டெஃபினேஷன் என்னன்னா, ஒரு அம்மோனியா அப்படின்றது இட்ஸ் ஹேவிங் அ ஃபார்முலா ஆஃப் NH3. By replacing the hydrogen presence in ammonia with one or two or all the three hydrogens by an alkyl or an aryl group, we are coming up with certain amine derivatives. அதுதான் amine. So for example, let's say I'm replacing one hydrogen and replacing it with a methyl group, so that's one amine. And one hydrogen with a phenyl group, two hydrogens with two methyl groups, and all the three hydrogens with all three methyl groups. So in a lot of amino structures are present. So we'll see the structures of amines. Like ammonia, nitrogen atoms of amine is trivalent and carries an unshared pair of electrons. So basically nitrogen has 2,5 configuration, in which 3 of them are valence and 3 of them are readily bonded because they are present in the 2p orbital. So this is electron configuration 1s2, 2s2, 2p3. I think that's right. Yeah. So in the 2p3 அப்படின்றது the more oftenly bonded type of atoms, and the 2s2 is obviously is in like it is in a complete configuration, and in p orbital as well we are having all the um, orbitals occupied. So there are 3 electrons that are available for bonding, which means it shows that nitrogen is trivalent more often and has a pair of lone pair in the outermost shell. So the outermost shell will generally have a pair of electrons that is unshared. So nitrogen orbitals in amines are therefore sp3 hybridized. So if we are having three bond pairs and one lone pair, then obviously it will form a sp3 hybridization. Okay, so and the geometry of the amines is pyramidal. So inge நம்ம நோட் பண்ண வேண்டிய பாயிண்ட் it is sp3 hybridized and the geometry is going to be pyramidal. Each of the 3 sp3 hybridized orbitals of nitrogen overlap with the orbitals of hydrogen or carbon depending upon the composition of the amines. ஸோ அதாவது ஒவ்வொரு sp3 hybridized, ஸோ இப்போ பாண்டிங் நடக்கும்போது என்ன ஆகும்னா ஒவ்வொரு நைட்ரஜன் லைக் பாண்டிங் ஆர்பிட்டால்ஸும் ஒரு sp3 hybridized ஆர்பிட்டலாக கன்வெர்ட் ஆகி அந்த ஒவ்வொரு sp3 hybridized ஆர்பிட்டாலும் either with s orbital of a hydrogen or a கார்பனோட sp or sp2 or sp3, anything is possible, or just p orbital, இந்த மாதிரி எந்த டைப் ஆஃப் காம்பவுண்ட்ஸ் வேணுனாலும் அக்கார்டிங் டு த காம்போசிஷன் பாண்டிங் நடக்கும் அப்படின்றத சொல்கிறாங்க. The fourth orbital of nitrogen in all amines contains an unshared pair of electrons. ஸோ கண்டிப்பாக ஃபோர்த் ஆர்பிட்டாலில் there is an unshared pair of electron அப்படின்றத சொல்லியிருக்காங்க. Let's just mark it out. Contains an unshared pair of electron. Due to the presence of unshared pair of electrons, the angle CNE, where E is certain, it can be either carbon or hydrogen, is less than 109 degree. For instance, it is 108 degree in the case of trimethylamine. So if it has to be in a pyramidal shape, then obviously it will have to carry a 109.5 degree angle between the carbon, nitrogen, and whatever the angle, it should be 109 degree. But since it has a lone pair on the other side, let's just draw it this way, which means there is a lone pair bond pair repulsion. Lone pair bond pair repulsion implies that this particular angle will shrink. It will shrink and finally lead to a certain angle less than 109.5 degree. For instance, let's say 108 degree in case of trimethylamine. Trimethylamine is basically the replacement of ammonia's hydrogens with 3 methyl groups. So that's how we are obtaining this particular structure. This is the structural composition of amines. Next, let's enter into the classifications. Amines are classified as primary, secondary, and tertiary depending upon the number of number of hydrogen atoms replaced by alkyl or aryl groups in the ammonium molecule. So obviously ammonia we have 3 hydrogens. Upon replacing it with 1 aryl or alkyl groups, 2 aryl or alkyl groups, or 3 aryl or alkyl groups, it is termed as primary, secondary, and tertiary. Unlike in case of alcohol, where we will have a nomenclature depending upon the carbon atom to which the hydroxyl group is attached. ஸோ கார்பன் ஆட்டம் என்ன டைப் ஆஃப் ஹைப்ரிடைசேஷன், என்ன டைப் ஆஃப் கார்பன் ஆட்டம் இருக்கோ அதை பேஸ் பண்ணி தான் ஆல்கஹாலோடைய ப்ரைமரியா, செகண்டரியா, டெர்ஷியா அப்படின்ட்டு டிஃபைன் பண்ணுவோம். ஆனால் இந்த கேஸில் அமைன்ஸில் வில் ஹாவ் the nomenclature according to the number of alkyl or aryl groups that is attached directly to the nitrogen. So we get, if one nitrogen atom or ammonia is replaced by an alkyl or aryl group, we get RNH2 or ARNH2, a primary amine. If 2 hydrogens, we will obtain a secondary amine. So what would we get? Okay, the second alkyl or aryl group may be same or different. Replacement of another hydrogen by alkyl or aryl leads to the formation of tertiary amine. Amines are said to be simple and all the alkyl or aryl groups are the same. So simple அப்படின்றது எப்போ சொல்லுவோம் அப்படின்னா, it is when it is of the form NH2R, NH2, NHR2, NR3. So இது எல்லாமே R will be the same. It will be simple. Mixedன்ற கேஸ் எப்போ வருதுன்னா NH2R, NH2R and on the other side we have having R dash, that is NHR and R dash, and I'm having N R R dash R double dash. So in the மாதிரி said to be simple when the alkyl or aryl groups are same and mixed when they are different. இதுதான் வந்து basic classification. Next we are entering into the nomenclature. In common system, an aliphatic amine is named by prefixing alkyl group to amine, that is alkylamine as one word. So common system நம்ம எப்படி பேஸ் பண்ணுவோம்னா simply it is termed as alkylamine, that is example methylamine. So for say let's say an example of ammonia converted into as CH3NH2, which means I am replacing one hydrogen with a methyl group. So how I'll define, I mean in common nomenclature it will be termed as methyl and amine. That's it, that's all about it in nomen. For secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is appended before the name of the alkyl group. In IUPAC system, so இப்போ நம்ம பேசுனது எல்லாமே common systemல, in IUPAC system primary amines are named as alkane amines. So இதில் common systemல it is termed as alkyl amines. IUPAC systemல we will have alkanamine. So that's the difference over here. Now let's see certain example. Let's say I have same CH3NH2. Okay, so this is basically methane. Methane is the alkyl group that is attached over here. Now what I'm gonna do is just replace this E and add a amine over here. So that's going to be methanamine. So it is termed as methanamine. In case more than one amino group is present at different positions in the parent chain, their positions are specified by giving the numbers to the carbon atoms bearing in H2 groups, and suitable prefix such as di, tri is attached to the amine. So if I say I have CH3NH2 on one end, let's say I have CH2, CH2, let's say I have NH2 over here as well, and CH3 over here. Now we'll start the nomenclature with the functional group having the least value. So we'll start the numbering over here with 1, 2 and 3. So in the particular case I'm having amine group that is attached to a carbon at the one end, and their second amine which is attached to the second carbon. So in this particular case okay, let's say we'll remove this as well. Then it is 1 ethane is the root word, and we will not remove any E from here. Rather we will just write the substituents value, and then we'll write a diamine because there are two amines. That's the case over here. So IUPAC system we'll write it as alkanamine. Common system we'll write it as alkyl amine, and depending upon the number of amine group we'll have di, tri, something like that prefixes, and the letter E of the suffix is retained. So to name secondary and tertiary amines we use locant N to designate substituent attached to a nitrogen atom. So let's say I have okay, for example I have CH3NHCH2CH3 is named as N-methyl ethanamine. N-methyl ethanamine. Okay, and if I have a tertiary amine it will be termed as N, N tri-diethyl ethanamine. Fine, diethyl ethanamine. So these are more examples. So basically if I'm having a secondary or a tertiary amine abdina, we'll use the locant name N, and with that locant name we'll name the remaining part of the chain, and then we'll already have an initial part, and then the initial part will be termed according to the length. So one side if I'm having 3 carbon abdina, it will be a propanamine obviously, and two other parts are let's say ethyl group, so it's going to be diethyl N-propanamine, which means it's a primary carbon. Now we can't have diethyl, we can have only ethyl. I think ethyl is the term, yes, and N is taken front over here, and it can be N, N if I have diethyl, or can be methyl, ethyl, propanamine, something like that. And this is the case where I have ethyl methyl ethyl propanamine. So this has three carbons. That's it. So we will take this as the longest chain, and this will be the substituent and the locant, and from here we will have the prefixes names. So in aryl amines, so we have seen now is just for aliphatic compounds. Let's see for certain aromatic, that is an aryl amine. In aryl amines, NH2 group is directly attached to the benzene ring. So let's say I have a benzene ring over here, right, with an NH2 group placed upon here. So this is the simplest example of an aryl amine. In common system, it is known as aniline. Obviously, it is an aniline in common system, which we have encountered a lot of times. It's also an accepted IUPAC name. Can be the only aryl amine with having both common and IUPAC names same is aniline. While naming aryl amines according to IUPAC system, so this is the naming. So the suffix e of arene is replaced by amine. Suffix e of arene is replaced by amine. So thus in IUPAC system, C6H5 NH2 is named as benzene amine. Okay. So it is just that the suffix e of the arene is replaced by amine. So if I have C6H6 and I'm turning it into a C6H5NH2, simply we'll just name it as benzene, and we'll remove a E and we'll add amine. That's it. That's all about it. So nomenclature of some alkyl amines and aryl amines. So this is ethyl amine, and this is ethanamine, propylamine, propanamine, N-propylamine, propan 1 amine, isopropylamine, propan 2 amine, and then I have ethyl methyl amine. Ethyl will be taken first, and then methyl, it will be named according to the alphabetical order. Whereas in the IUPAC naming system, we'll consider the longest chain first as the root word. So this is going to be ethanamine with a methyl group attached to the nitrogen on the other end. So we'll have N-methyl ethanamine. Right. So if I have okay, this is trimethylamine, but in case of IUPAC system, we'll have a N, N in the first place. We'll take the two other guys as substituents and name it as dimethyl, and then we have the remaining as the root word, and we'll term it as methanamine. Okay, so next here I'm having another tertiary carbon. So here all like two groups are different. So first we'll have to write N, and there are two substituents, so that will be named as diethyl, and then we'll write butylamine. That's important. For common name it is butyl, and for IUPAC naming it's butanamine. Okay, fine. Then numbering will start only from the functional groups carbon, so it should be from 1 2 3, which means that it's a primary amine. It is propene. I mean, like, it's actually allylamine, and then in terms of prop 2 in 1 amine. Okay, now let's term it in IUPAC nomenclature. First we'll have to write a prop, and then we'll have to write a 2 in, and we'll replace the E with the amine, and that will be on 1 amine. Prop 2 in 1 amine, so that will be the actual name. In case of aryl, generally it is called as aniline, and this is called as orthotoluidine. This is parabromoaniline, and this is N, dimethyl and this is L, dimethyl benzenamine. Okay, now let's start with IUPAC naming. This is aniline, but we'll take the arene group, benzene, and then we'll replace it with an amine. We'll remove the E and with an amine. So that's benzene amine. So here we'll take the aryl group. So it's actually methylaline, met- 2-methylaniline. Okay, fine. But it's actually orthotoluidine. Tolu, toluene is actually benzene with the CH3 group attached to it. So we'll convert it into orthotoluidine. In the ortho position, we are having an amine group. So toluidine amine. So toluene derivative with an amine in the ortho position is toluidine. Okay, and then I have 2-methylaniline. Okay, wait a minute. So basically aniline will be the root word because NH2 will be having a priority over methyl group. So aniline with the ortho position of methyl group, it's a 2-methyl aniline. So that's the word it seems. This is actually para-bromoaniline, but in actual word it's a 4-bromo benzenamine. Bromo because when it is a substituent we'll have a prefix of bromo, and it's a benzene amine. Obviously we'll have to write the root word and we'll replace the E with an amine. And here it's a tertiary nitrogen, which means we'll have to use N comma N, and we'll write the substituents as dimethyl, and then we'll write the actual root word. The root word is benzene with the E replaced with an amine, so benzene amine. So that's the IU part. Classify the following as, so this is a primary amine has, and this is a tertiary amine, primary amine, secondary amine. Right. Write the structures of different isomeric amines corresponding to the molecular formula C4H11N. First, we'll have to check for the degree of unsaturation. 4 plus 1 minus 11 plus 0 minus 1 by 2, which is 5 minus 10 by 2 is 0. So it is a open chain aliphatic compound. So first we'll write 1, 2, 3, 4. We'll write NH2. We'll have 3, 2, 2. That's 7. 7, 9, and 11. Yeah, it's perfect. So this is the first structure. So in the side ரெண்டுமே same தான். At the second structure, it's going to be NH2 over here. So that's fine. We don't have any double bond, so we'll enter into the second one. 1 replaces the nitrogen, so it's 1, and then 2, 1, 2, 3, 4 with 3, 3, 6, 2, 2, 10, 11. So in the position, wait a minute, 1, 2, 1, 2, 4. So these are secondary amines, and I think it is a steric center as well, but it is not a steric center. It's a primary amine with a steric center, and it's over here. ஸோ இங்கேருந்து 2 வரும், இங்கேருந்து 2 வரும், இங்கேருந்து 2 வரும், இங்கேருந்து 1 வரும். அடுத்து டெர்ஷியரி அமைன் 1, 2, 3, 4. 1, 2, 3, 4, 6, 6. I mean, say 3, 3, 6. 6 plus 2. Sorry. 3, 3, 6. 6 plus 2, 8. 8 plus 3, 11. ஆகாய கங்கை பொன்மேன் மலர் தோழி சீதாபுகழ் ராமன் பாடம் தொட்டு ராகம் தொட்டு பாடுவார். இப்படியும் போடலாம், இப்படியும் போடலாம், இப்படி போட்டாலும் ஒன்று தான். மன்னாதியே ஒரு வாசம் மஞ்சள். So it's 1, 2, 2, 5 plus 2 is 7. So I have 7 isomeric amines. Hope it is 7. Let's see. Write IUPAC name of all the isomers. So it's 1, 2, 3, 4. Start numbering from here. 1, 2, 3, 4. It is butane 1 amine. We'll have to remove 1. Butane 1 amine. Butane 2 amine. Now we are having N methyl propane 1 amine. N ethyl ethane 1 amine. N, N dimethyl ethane 1 amine. So that's it. I think I'm done. Right, what type of isomerism is exhibited by different pairs of amines? 1 and 2 chain isomerism, yeah, and then 1, 3, 1, 4, 1, 5 are all functional isomers. அதே மாதிரி 2, 3, 2, 4, 2, 5 are all functional isomers. 3, 4 are chain isomers, and 3, 5 are functional isomers. What else we have? Chain, functional, ring chain we do not have. Tautomerism, can we say it as tautomers? Metamerism is available for 3 and 4 because we have two different ethyl groups, aryl alkyl groups attached to the nitrogen. And in 2 and 3 we have optical isomerism because there are one stereo center each, which means we'll have two different isomers that rotates the plane polarized light in different directions. So let's just from here. Preparation. Now we are entering from IUPAC into preparation of amines. Amines are prepared by the following methods. Reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas. Okay, I think we'll have to have a break. Okay, continuing from preparation of amines. Amines are prepared by the following methods. ஸோ அதாவது இப்போ அமைன்ஸ் ப்ரிப்பரேஷன் பற்றி பார்க்க போகிறோம். அமைன்ஸ்க்கு வந்து சில ப்ரிப்பரேஷன் மெத்தடாலஜிஸ்லாம் இருக்குது அப்படின்ற சொல்லியிருக்காங்க. ஃபர்ஸ்ட் ஆஃப் ஆல் நம்ம இது கொஞ்சம் கட் ஷார்ட்ஸ் பண்ணிக்குவோம். கட் ஷார்ட்ஸ், யப், பர்ஃபெக்ட், யா. ஸோ ரிடக்ஷன் ஆஃப் நைட்ரோ காம்பவுண்ட்ஸ். இப்போ நைட்ரோ காம்பவுண்ட்ஸ் அப்படின்றதுல பேசிக்கலி NO2 டைப் ஆஃப் காம்பவுண்ட்ஸ் அப்படின்றத ரெடியூஸ் பண்ணுற மூலயமா we are removing the oxygen and time converting into NH2 parts. இதுதான் பேசிக்கலி பண்ண போகிறோம். Nitro compounds are reduced amines by passing hydrogen gas in the presence of finely divided nickel, that palladium or platinum, and also by reduction with metals in acidic medium. So metals in acidic medium அந்த பேசிஸ்லையும் பண்ணலாம், இல்லைனா ஜஸ்ட் ஃபைன்லி டிவைடட் நிக்கல், பல்லாடியம், பிளாட்டினம் இந்த மாதிரி சில முக்கியமான கேட்டலிஸ்ட், மெட்டல் கேட்டலிஸ்ட் மூலியமாகவும் ஹைட்ரோஜனேஷன் பண்ணுறது மூலியமாகவோ இல்லை ரெடியூசிங் ஏஜென்ட்ஸை பயன்படுத்துகிற மூலியமாகவோ we can reduce the metals and reduce the nitro compounds into NH2. Nitroalkanes can also be similarly reduced to the corresponding alkanamines. But let's see certain examples. Now I have an aryl amine, aryl nitro compound. So this is a aryl nitro compound. So in the particular nitro compound I will have to convert it into a aniline. Let's say I am converting it to aniline. ஸோ இந்த பர்டிகுலர் கேஸில் இதனால் பேசிக்கலி NO2 ரிடக்ஷன் பண்ணணும் அப்படின்னா லைக் பாய்சன் பேசிஸில் ஹைட்ரோஜனேஷன் பண்ணுறது மூலியமாகவோ அல்லது ரெடியூசிங் ஏஜெண்ட் இன் ப்ரெசன்ஸ் ஆஃப் அசிடிக் மீடியம் பயன்படுத்துகிற மூலியமாகவோ ஒரு ரிடக்ஷன் நடக்கும். ஏன் அசிடிக் மீடியம் பயன்படுத்துகிறோம்? அசிடிக் மீடியமில் H+ கான்சன்ட்ரேஷன் அதிகமாக இருக்கும். H+ கான்சன்ட்ரேஷன் அதிகமாக இருக்குது. ஆப்வியஸ்லி it can go and remove the oxygen can be removed in presence of this particular metal, and the acidic medium will take care of the remaining part. It will convert it into NH2. Reduction with iron scrap and hydrochloric acid preferred because ஸோ இப்போ இந்த பர்டிகுலர் கேஸில் Fe+HCl இதுதான் வந்து மோர் ப்ரிஃபர்ட் அப்படின்னு சொல்கிறாங்க. ஏன் அப்படின்னு பார்ப்போம். ஃபவுண்ட் gets FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. So more preferred ஏன் அப்படின்னா, ஃபர்ஸ்ட் ஆஃப் ஆல் இந்த பர்டிகுலர் கேஸில் FeCl2 அப்படின்றது ஃபார்மேஷன் ஆகும் அப்படின்னு சொல்கிறாங்க. இது வந்து it gets hydrolyzed in presence of like water or something like that, and it again releases HCl and again releases with Fe, and it again forms FeCl and it again hydrolyzes to form HCl and again gets reacted with Fe to form FeCl2, and this small amount of HCl that is reacting with Fe will keep on giving up hydrochloric acid that is required for the rest of the reaction to grow. So இதுதான் வந்து இந்த முக்கியமான பார்ட்டு. ஸோ என்னதுன்னா, the iron scrap and hydrochloric acid is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid அப்படின்னு சொல்கிறாங்க. நெக்ஸ்ட் அம்மோனோலைசிஸ் ஆஃப் alkyl halides. ஸோ இப்போ வந்து அல்கைல் ஹேலைட்ஸை அம்மோனோலைசிஸ்னால் என்ன பார்ப்போம். ஹைட்ராலிசிஸ்னால் நமக்கு என்ன தெரியும், பேசிக்கலி we'll use OH minus H+ and we'll add them, and somewhere we'll just remove the unnecessary part that's being produced. So அதே மாதிரி சிமிலராக we'll have NH2 minus H+ and something related to that is going to happen over here as well. Let's see what it is. We have read in unit 6 of class 12 that the carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. அதாவது ஒரு கார்பன் ஹாலோஜன் பாண்ட் அப்படின்னா, halogen will be more electronegative, which means it will have a partial negative charge, and carbon will having a partial positive charge. And ஒரு நியூக்ளியோஃபைல் அட்டாக் பண்ணணும். நியூக்ளியோஃபைல் அட்டாக் வந்து கார்பனில் நடந்தது அப்படின்னா ஆப்வியஸாக வந்துட்டு இந்த பர்டிகுலர் பாண்ட் வில் ரிமூவ். ஏன்னா ரெண்டு காரணம். ஒன்று வந்து கார்பன் இஸ் பிகமிங் கார்பன் இஸ் existing as a partial positive charged compound, and a nucleophile is requiring that, and that condition is satisfied. Next, in the particular bond break ஆகிறதுக்கு காரணமாக X will bear a negative charge, which is favorable condition because X will be electronegative, which means it can carry the negative charge. So it can be easily cleaved by a nucleophile. So the carbon oxygen bond can be easily. So இப்போ இதை வச்சு என்ன பண்ண போகிறோம். Hence an alkyl or a benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reaction. ஸோ ஒரு alkyl இல்லை பென்சைல் ஹாலைடு வந்து ஒரு ஈத்தனாலிக் சொல்யூஷன், ஒரு ஆல்கஹாலிக் சொல்யூஷனில் வந்துட்டு ஒரு அம்மோனியாவோட என்ன டைப் ஆஃப் ரியாக்ஷன் கொண்டு அண்டர்கோ பண்ணுது அப்படின்னா, இட் இஸ் கோயிங் டு அண்டர்கோ nucleophilic substitution reaction in which the halogen atom is replaced by an ammonia group. So this process is the cleavage of CX bond by ammonia molecule known as ammonolysis. So ammonolysis na enadhu, the cleavage of CX bond by ammonia molecule is called ammonolysis. மோனோலைசிஸ் அப்படின்னு சொல்கிறாங்க. ஸோ பேசிக்கலி நம்ம என்ன பண்ணுறோம், ஒரு ஈத்தனாலிக் சொல்யூஷனில் ஒரு அல்கைல் அல்லது பென்சைல் ஹாலைடை நம்ம ஈத்தனாலிக் சொல்யூஷனில் அமோனியாவோட ரியாக்ஷன் பண்ண வைக்கும் பொழுது there will be a nucleophilic substitution where the nucleophile is going to just attack the alkyl group, and the X minus part will basically remove, forming a negative charge particle. Okay, this process of cleavage of CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. So basically 373 Kelvin வந்து இந்த particular reaction go through ஆகும் அப்படின்றத சொல்கிறாங்க. Which means it requires some amount of energy, external energy for this reaction to occur. The primary amine thus obtained behave as a nucleophile and can further react with alkyl halide to form secondary and tertiary amine. ஸோ இப்போ இந்த பர்டிகுலர் கேசஸில் என்ன நடக்குது அப்படின்னா, ஒரு பிரைமரி அமைன் நமக்கு ஃபார்ம் ஆகும். ஸோ அந்த பிரைமரி அமைன் will act as a nucleophile. ஸோ இப்போ இந்த nucleophile will again attack with another RX bond, another molecule of RX. ஸோ இந்த RX bond மறுபடியும் cleavage நடக்கும், இந்த nucleophile attack நடக்கும். ஸோ இப்போ finally will obtain a RNHR type of a bond, and again with another molecule of RX or alkyl halide, it finally can form RNR as well, and can also further go to form a quaternary ammonium salt R4N minus X plus type of N plus X minus type of compound formation-க்கும் chances இருக்குது. ஸோ இப்போ இதுதான் வந்து இந்த அமோனோலைசிஸ்ன்ற கான்செப்ட். The free amine can be obtained from the ammonium salt by treatment with a strong base. ஸோ இந்த ஃப்ரீ அமைனை வந்து நம்ம ஜஸ்ட்டு எப்படி ரிமூவ் பண்ணலாம் அப்படின்னா, ஸ்ட்ராங் பேஸோட நம்ம ரியாக்ஷன் பண்ணும்பொழுது we can obtain the அப்படின்ற மாதிரி சொல்கிறாங்க. ஏன் அப்படின்னா, there's a halogen is being electronegative, and the hydrogen that is being at least van der Waals force இல்லை ionic bond மூலிமா bond ஆகியிருக்க அந்த hydrogen is going to be acidic hydrogen. So it's going to be an acid base kind of reaction which leads to the formation of Na plus X minus will combine together to form a NaX, and similarly water will be obviously precipitated. It's a acid base reaction, and we are obtaining the free amine. ஸோ ஃப்ரீ amine அப்டேட் பண்ணோம் அப்படின்னா ஒரு ஸ்ட்ராங் பேஸோட ரியாக்ட் பண்ணணும் அப்படின்ற சொல்கிறாங்க அமோனியா சால்ட்டை. அமோனோலைசிஸ் ஹேஸ் த டிஸ்அட்வான்டேஜ் ஆஃப் yielding a mixture of. ஸோ இதில் இருக்க டிஸ்அட்வான்டேஜஸ் என்ன அப்படின்னா, இதுதான் டிஸ்அட்வான்டேஜ். அதாவது என்னென்னா, இந்த ரியாக்ஷன் வந்துட்டு நம்மளால் கண்ட்ரோல் பண்ண முடியாது. இட் கேன் லீட் டு த ஃபார்மேஷன் ஆஃப் அ குவாட்டர்னரி அமோனியம் சால்ட், வேரஸ் we will need only primary salt. அப்போ அந்த பர்டிகுலர் கேஸில் என்ன பண்ணலாம், primary amine is obtained as a major product by taking large excess of ammonia. ஸோ இப்போ இதை எப்படி நம்ம கண்ட்ரோல் பண்ண முடியும் அப்படின்னா, அம்மோனியாவுடைய கான்சன்ட்ரேஷன் வந்து எக்ஸஸில் எடுத்துக்கிட்டோமே ஆனால் கண்டிப்பாக நமக்கு வந்துட்டு ப்ரைமரி அமைன் வில் பி மேஜர். இல்லை அப்படின்னா அல்கைல் ஹேலைட்ஸ் வந்துட்டு ஃபர்தராக வந்துட்டு ரியாக்ஷன் நடந்துக்கிட்டே போவதன் காரணமாக ஆப்வியஸாக நமக்கு வந்துட்டு குவாட்டர்னரி அம்மோனியம் சால்ட்டு தான் வந்து மேஜர் ப்ராடக்டாக கிடைக்கிறதுக்காக சான்ஸ் இருக்குது அப்படின்றது தான் இந்த பர்டிகுலர் கேஸில் இருக்கிற அவுட்கம். So next we will enter into certain questions. So write the chemical reactions for the following. Reaction of ethanolic NH3 with C2H5Cl. ஸோ இப்போ என்ன சொல்கிறாங்கன்னா, C2H5Cl அதோட அம்மோனியா இன் இத்தனால் அப்படின்னா இப்போ கண்டிப்பாக இட் இஸ் கோயிங் டு பி அ cleavage of CCl bond leading to the formation of the first reaction. First reaction we will obtain C2H5, Cl will be removed, and I will have NH2 plus HCl, something like that will be formed. And again, if it is reacting with ammonia, if I am having excess of ammonia, this will be the final product. If I am having excess of C2H5Cl, then I will obtain C2H5N C2H5. It's a triethyl ammonia, that's something like that. So ethanolic ammonia with C2H5Cl is going to be the reaction in two cases. Ammonolysis of benzyl chloride na basically a benzene ring with a chlorine, that is benzyl ring, benzyl chloride, and reaction of amine so formed. So we'll have to first do ammonolysis. So let's say I am obtaining the formation of NH2. Reaction of amine so formed with 2 moles of CH3Cl. So 2 moles of CH3Cl na obviously CH3 in the பக்கம், CH3 in the பக்கம். So it's going to be a N, dimethyl benzene amine. அதுதான் ஃபார்ம் ஆகுது. Next, C2H5Cl with ammonia gives this. Oh, they have given the solution. Dimethyl phenylamine. Okay, 1 minute. ஓகே, பென்சைல் குளோரைட் கொடுத்துருக்காங்களே. ஓகே, அவங்க அரைல் குளோரைட் கொடுக்கல. அரைல் குளோரைட்னா இட் இஸ் கோயிங் டு பி chlorine directly attached. Fine, great. Moving on, reduction of nitriles. So we are entering into reduction of nitriles. So we'll just remove this part and keep it over there. Okay, yeah, reduction of nitriles. Nitriles on reduction with lithium aluminum hydride. அதாவது நைட்ரல்ஸ்னால் பேசிக்கலி C triple bond N. C triple bond Nன்றது பேசிக்கலி இட் வில் பி எலக்ட்ரான் ரிச் சென்டர். எலக்ட்ரான் ரிச் சென்டரில் அப்படின்னா கண்டிப்பாக தெர் வில் பி லைக் இஃப் யூ ஆர் ஆக்சிடைசிங். ஓகே, வி ஹாவ் டு ரெடியூஸ் இட். வெயிட் அ மினிட். ரிடக்ஷன் பண்ணுறது மூலியமாக ஐ எம் கோயிங் டு அப்டைன் அமைன் அப்படின்ற மாதிரி சொல்கிறாங்க, விச் மீன்ஸ் இட் இஸ் ஹேவிங் அ லாட் ஆஃப் ஆக்சிடைஸ்டு ஸ்டேட் அப்படின்ற மாதிரி சொல்ல வராங்க. ஓகே, ஃபைன். So basically this guy is an sp hybridization, I think. Yeah, it's sp hybridization. One lone pair, one bond, one sigma bond. Yeah, so nitriles on reduction with lithium and aluminum hydride or catalytic hydrogenation produce a primary amines. This reaction is used for the ascent of amine series, that is for the preparation of amines containing one carbon atom more than the starting carbon amine. அதாவது இப்போ இது வந்து அப்பு ஸ்டெப் அப் ரியாக்ஷன் அப்படின்னு சொல்லுவாங்க. ஸோ இதை ஸ்டெப் அப் ரியாக்ஷன் அப்படின்னா பேசிக்கலி வில் ஹாவ் ஒன் மோர் கார்பன் ஆட்டம் தேன் த எக்ஸிஸ்டிங் அல்கைல் குரூப் ப்ரெசன்ட் தட் இஸ் பாண்டட் வித் அமைன். என்ன நடக்கும் அப்படின்னா RC ட்ரிபிள் பாண்ட் என்ன வந்துட்டு ஐதர் பை ஹைட்ரோஜனேஷன் ஆர் பை லித்தியம் அலுமினியம் ஹைட்ரைடு ரிடக்ஷன். ஹைட்ரோஜனேஷன் அப்படின்றது இன் ப்ரெசன்ஸ் ஆஃப் நிக்கல் கேட்டலிஸ்ட் அப்படின்றத பயன்படுத்தலாம். இல்லை சோடியம் அமால்கம் இன் இத்தனால் இந்த மாதிரி எந்த விஷயம் வேணாலும் பயன்படுத்தலாம். will always obtain RCH2 NH2. So we will not have the mechanism over here. That's fine. Next, amide. So amide na basically we will have RC double bond N C double bond O NH2. So it's simple. Basically நம்ம C double bond O group மட்டும் நம்ம convert பண்றோம்னா it's going to convert into an amide. And for this particular conversion we are having like I think we have two types of converters. One is Wolff-Kishner reduction and another one is lithium aluminum hydride reduction. ஸோ ரெண்டுமே வந்துட்டு நமக்கு இந்த பர்டிகுலர் ப்ராடக்ட்டை தரும். நெக்ஸ்ட்டு முக்கியமானது கேப்ரியல் தாலமைட் சிந்தசிஸ். ஸோ கேப்ரியல் தாலமைட் சிந்தசிஸில் என்ன கொடுத்துருக்காங்கன்னா the Gabriel Thalmide is Gabriel synthesis used for the preparation of primary amines. So it is only for primary amines. So no other amines can be produced. Let's just change the color. Yeah. Yes. Thalamide on treatment with ethanolic potassium hydroxide. Ethanoic potassium hydroxide, which means it's an alcoholic solution in which I am using potassium hydroxide KOH, forms potassium salt of thalamide. So thalamide அப்படின்றது okay, potassium salt of thalamide. So thalamide will undergo certain acid base reaction because this guy over here, the hydrogen over here, it is attached to electronegative atom, which means this hydrogen is an acidic hydrogen. Upon reaction with a base, it will deprotonate this and form a N plus and N minus and a K plus will form a salt, that is Gabriel thalamide salt. This is thalamide salt, potassium salt of thalamide, which on heating, so if I am heating with alkyl halide, so I am heating with alkyl halide, so basically it will give Kx plus Nr, so that's going to be the reaction, that is N alkyl thalamide, followed by alkaline hydrolysis. Alkaline hydrolysis அப்படின்னா I am going to basically use water, hydrolyze it in presence of a basic medium. So basic medium la hydrolyzing this C double bond O N NR, so it's going to give aromatic primary amines cannot be prepared by, okay fine, it produces the corresponding primary amines. So basically என்ன நடக்குது அப்படின்னா இந்த particular N bond break ஆகி we are obtaining a hydrogen but attached to the nitrogen part I am obtaining a NH2R, that is the primary N, and the remaining part that doesn't matter. So the aromatic primary amines cannot be prepared by this method. ஏன் அப்படின்னா aryl halides do not undergo nucleophilic substitution with the anion found by the thalamide. So basically என்னன்னா இந்த particular caseல if I am having an aryl amide, let's say I have aryl amide, okay, aryl halide. So nucleophilic substitution undergo பண்றதுக்கு we will have to undergo some other process. I mean like anion இந்த R KX formation and இங்க வந்துட்டு NR, இந்த NR க்கு பதிலா இந்த N aryl வரணும் அப்படின்னா it has to undergo substitution, which is not possible. ஏன்னா substitution reaction will not undergo in aryl amines, aryl halides. We'll have to use some other type of reactions like elimination type of reactions will be useful in, or addition products will be useful. So we cannot use. So aromatic primary amines cannot be prepared by this method. The reason being the aryl halides do not undergo nucleophilic substitution with the anion found by the thalamide. Okay, fine. Next we have Hoffman bromide degradation. Hoffman bromide degradation is one another important type of reaction. So basically we will use a base and alkyl halide to obtain the reaction. Okay, let's see what it is. So it's a step down reaction as well. Obviously we'll have to remove one step down reaction. Okay, so LAH use பண்ணோம்னா C double bond O group வந்துட்டு it will convert it into CH2, whereas in Hoffman bromide degradation C double bond O group will vanish. So that's what is happening over here. Hoffman developed a method for preparation of primary amines by treating an amide. So this is an amide with an bromine in aqueous or ethanolic solution. So bromine is going to be used, not any other halide, and I'm using a basic medium or a ethanolic solution, something like that. In this degradation reaction, migration of an alkyl group or an aryl group takes place. So in the particular reaction we'll have something called as migration. So we'll have the migration of an alkyl or aryl group from carbonyl carbon of the amide to the hydrogen atom. அதாவது carbonyl carbon of the amide. அதாவது இந்த particular amine அப்படின்றது it will migrate and it will travel over here to obtain this particular formation RNH2. So the amine form so contains one carbon less than the present in the amide. So the முக்கியமான கேஸ் என்ன அப்படின்னா it will have one carbon less than that present in the amide அப்படின்றது தான் இந்த particular case. So basically we are having 1 mole of amide with 1 mole of Br with 4 moles of NaOH. 4 moles is required for this particular reaction to give an yield of RNH2, sodium carbonate, sodium bromide and water. Okay, yield பண்றதுக்கு இதெல்லாம் தேவைப்படுது அப்படினு சொல்றாங்க. Fine. Yeah, write the chemical equations for the following conversions. So I am converting chlorine to NH2 chlorine conversion வந்துட்டு I have to cleavage பண்ணனும் அப்படினா I'll have to use ammonia in presence of basic medium or something like ethanol alcoholic medium. That is fine. And step up reaction பண்ணுறதுக்கு நைட்ரைலாக கன்வெர்ட் பண்ணணும். ஸோ we'll first use KCN ஓட ஆட் பண்ணிட்டு அதுக்கப்புறம் we'll have to use LAH for obtaining CH2. Okay, fine. Ethanolic NaCN is also fine. Okay, 1 minute. I think I can use LAH as well, right? Reduction of, yeah, LAH is also fine, or I can use catalytic hydrogenation. Both reactions can give the required product. Write the structures and IUPAC names. The amide which gives propanamine by high. So okay, so basically there is certain amide. Okay, I'm using Hoffman bromide degradation giving rise to propanamine RNH2. So obviously this will be R is going to be CH3 CH2 CH2 C double bond O NH2. Okay, fine. So I'll have to give the IUPAC name as well. The C double bond O group will be considered a major group over here, I think, and it is an amide, propanamine. So it's butanamide. That's it. Okay, fine. It's butanamide, it seems. It's actually butanoic acid. We are having acid derivative of amine over here. So basically it's amide. So butanoic acid with an amide derivative gives a butanamide. So that's how we'll write the IUPAC name. Amine produced by Hoffman degradation of benzenamide. It's going to give me aniline. But wait, we'll have to give the product. Produced by Hoffman benzenamide NC double bond NH2 will give me aniline. Aniline is also written as benzenamine. Yeah, how will you convert benzene into aniline? NH2 has to be added. First we can do nitration. Nitration can be done by Na, like NO2 in presence of sulfuric acid, and then reduction can be done by hydrogenation, or anything is like in acidic medium நம்ம yeah, anything can be done. Benzene into N, N dimethyl aniline. So first NO2 கன்வெர்ட் பண்ணணும், அடுத்து NH2 கன்வெர்ட் பண்ணணும். NH2 ஓட மித்தைல் ஹாலைடு மித்தைல் குளோரைடு ஒரு 2 moles ஆஃப் மித்தைல் குளோரைடை வந்து ரியாக்ட் பண்ணும்போது ஐம் ஆப்டேக்கிங் N, dimethyl aniline. So we'll have to convert 2 chlorines into amines. Okay, 2 chlorines into amines means we'll have to use certain substitution reactions. Chlorine cleavage with amine can be done by ethanolic okay, in ethanolic solution we can use ammonia with 2 moles, so we can obtain this particular reaction. Yeah, for the second reaction, and we are done with only 7 pages, and we'll have to go for another 13 pages. I think we can do this. Yeah, we can do this. So now we are entering into the physical properties. The lower aliphatic amines are gases with fishy odor. Fishy odor means okay, fine. Primary amines with 3 or more carbon atoms are liquid, still higher ones are solid. Aniline and other aryl amines are usually colorless but get colored on storage. Okay, so basically first physical property என்னன்றத பார்ப்போம். It is a fishy odor with lower aliphatic amines. Okay, primary amines with 3 or more carbon atoms are liquid, still higher ones are solid. Okay, 3 or more carbon atoms are liquid, still higher ones are solid. So if I'm having max of 3 carbon atoms, then it's going to give me liquid primary amine. Okay, fine. Aniline and other aryl amines are usually colorless but get colored on storage due to atmospheric oxidation. So basically they are colorless, aniline and aryl amines, but these guys upon storage due to atmospheric oxidation will get colored அப்படின்ற சொல்றாங்க. So that's the first set of physical properties that we are obtaining. Next, the lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. Okay, so lower aliphatic amines are soluble in water. So next they are talking about solubility. Initially they talked about the physical orders like smell and color and physical state. Now they are talking about the lower aliphatic amines are soluble in water because they can form hydrogen bonds with water molecules. Yeah, that's fine. However, the solubility decreases with increase in molar mass of amines due to the increase in the size of the hydrophobic alkyl part. Okay, fine. The higher amines are essentially insoluble in water. Considering the electronegativity of nitrogen of amine and oxygen of alcohol as 3 and 3.5, you can predict the pattern of solubility of amines and alcohols. Out of butane 1-ol and butane 1-amine, which one will be more soluble and why? Amines are soluble in organic solvents like alcohol, ether, and benzene. You may remember. Okay, basically the electronegativity of oxygen will be higher, which means the bonding with water will be higher for alcohols, which means the solubility of alcohols will be greater than that of amines. And next, that's the reason. Amines are soluble in organic solvents like alcohol, ether, and benzene. Okay, fine. They basically form bonds with alcohol, ether, and benzene. That's what they're trying to say over here. You may remember that alcohols are more polar than amines and form strong intermolecular hydrogen bonds than amines. So that's what they're trying to imply over here as well. So amines are basically soluble in water but less soluble than alcohols, and they are soluble in organic solvents like alcohols, ethers, and benzenes. And yeah, higher amines are insoluble in water. Primary and secondary amines are engaged in intermolecular association due to hydrogen bonding between nitrogen of one and hydrogen of another molecule. This intermolecular association is more in primary amines than in secondary amines, as there are 2 hydrogen atoms available for hydrogen bond formation in. அதாவது primary and secondary amines இரண்டுமே வந்துட்டு will associate in hydrogen bonding. ஏன் அப்படின்னா they will have basically one hydrogen, and the hydrogen bond will be nitrogen of one and hydrogen of another. This intermolecular association is more in primary than in secondary, and there are 2 hydrogen in available for the bond formation. Tertiary amines do not have intermolecular association due to the absence of okay, therefore the order of boiling points of isomeric amines. Primary will have more boiling point because they will have more intermolecular association due to the presence of hydrogen atoms that can form bond easily with another nitrogen. And that will be lesser for secondary because it will have only one hydrogen, and tertiary will have no hydrogen, which means it will have least boiling point. So boiling points of amines alcohols and alkanes are of almost same molar mass as shown. Okay, so let's first order them out. 300, I think this is first one. 310 is the second one. 329 is the third one. Fourth one, fifth one. So yeah, I'm having a primary amine, secondary amine. Primary amine has the highest boiling point, it seems. No. Alcohol has the highest boiling point, followed by primary amine, secondary amine, and then tertiary amine, and then we have alkane. So that's how it works. Fine. Chemical reactions. So we have seen the physical properties. So some of them will be liquid, most of them will be solid in the higher part, and then solubility was checked. And we talked about the boiling point, that is also checked. And the boiling point difference between alcohols and amines is also checked. Fine. I think we'll have to take a break, but it's only 1 hour done. And that we already had 20 minutes of break, which means we have done only 40 minutes of work. So yeah, it's going long. Okay, we'll complete till diazonium. We'll leave diazonium alone for now. I think that would be fine for now. So I'll have to push up 7 pages for the next 40 minutes. I think that is possible. Now let's enter into chemical reactions. Difference in electronegativity between nitrogen and hydrogen atoms and the presence of unshared pairs of electrons over the nitrogen atom makes amines reactive. So basically amines are having nitrogen atoms bonded with hydrogens, and there is an electronegativity difference between nitrogen and hydrogen, and there is also an unshared pair of electrons present in nitrogen, which means that they are reactive. The number of hydrogen atoms attached to the nitrogen atom decides the course of reactions, that is why primary, secondary and tertiary differ in many reactions. Moreover, amines behave as nucleophiles due to the presence of unshared electron pair. They can also act as nucleophiles. They can have different reactions for different amount of amines. Some of the reactions of amines are described below. So yeah, let's see, that's what we can do. Amines, being basic in nature, react with acids to form salts. So amines are basic in nature, so they react with acids. So that is the basic character of amines, that is they will undergo acid base reaction. Okay, fine, because amine has an unshared pair of electron which will act as a Lewis base. So that's the first character, the basic character of amines. Next, the amine salts on treatment with a base like NaOH regenerate the parent amine. So if I have an amine salt and upon reaction with a base, some other base or something except the salt formed, it will regenerate the amine. So this is one important part. Regeneration of the parent amine can be done in amines. The amine salts are soluble in water but insoluble in organic solvents. It is soluble in water, insoluble in organic solvents like ether. Amine salts, we are talking about amine salts over here. Okay, we are talking about amine salts over here. Amine salts like ether. Okay, this reaction is the basis for the separation of amines from the non-basic organic compounds insoluble in water. So from this property only, we will basically separate the amines from the non-basic organic compounds insoluble in water. Okay, separation of amines can be done due to this. Okay, so என்ன சொல்ல வராங்க is the basis for the separation of amines from non-basic organic compounds. So the certain organic compounds will not be basic, which means they will not have a lone pair, or they don't have the tendency of accepting an electron. Those kind of organic compounds will be separated from the amines. Okay, due to this, fine. The reaction of amines with mineral acids to form ammonium salts show that these are basic in nature. Yes, amines have an unshared pair of electrons. They behave as Lewis as base. Basic character of amines can be better understood in terms of their Kb and pKb. So let's say I have a reaction RNH2 which upon hydrolysis give RNH3 plus OH minus, which means it's a acid base reaction where NH2 is acting as a base, deprotonates water, leading to the formation of OH minus, increasing the concentration of OH minus and forming RNH3 plus. So the equilibrium constant can be written in terms of the concentration of the reactants, like reactant concentration of products, concentration of RNH3 plus multiplied by concentration of OH minus divided by concentration of RNH2. It can be a solid in most cases, several cases, and concentration of water. So K into concentration of water will give me the Kb value. So that's the Kb value actually, and Pkb is the negative log of Kb value. That's it. So the larger the value of Kb or smaller the value of Pkb, stronger is the base. The Pkb values of few amines are given. That is, I don't think I'll have to remember it. Pkb value of ammonia is 4.75. Aliphatic amines are stronger bases. Aliphatic amines are stronger bases than ammonia due to plus A effect of alkyl group leading to the high electron density. The Pkb values lie in the range of 3 to 4.22. On the other hand, aromatic amines are weaker bases than ammonia due to the electron withdrawing nature of the aryl groups. So aromatic amines are basically weaker bases and aliphatic amines are stronger bases than ammonia. So the basicity follows this order: aryl amines or aromatic amines followed by ammonia will be higher, and which ammonia which is smaller than aliphatic amines. So that is the basicity. So they have given certain pkb values as well. We can actually get this, and I don't think we'll have any okay, you may find some discrepancies while trying to interpret the kb values of amines on the basis of plus or minus 5 effect of the substituents present in amines. Besides inductive effect, there are other effects like solvation, steric hindrance, which affect the basic strength. Just ponder over, you may get the answer in the following paragraphs. So இப்போ இந்த பர்டிகுலர் டேபிள் நம்ம அனலைஸ் பண்ணோமே ஆனால் நமக்கு சில டிஸ்கிரிப்பன்சிஸ் வரும். ஏன்னா இண்டக்டிவ் எஃபெக்ட்ஸை தவிர்த்து நம்ம சில எஃபெக்ட்ஸ் லைக் சால்வேஷன் எஃபெக்ட்ஸ், ஸ்டீரிக் ஹிண்ட்ரன்ஸ் அண்ட் இதெல்லாமே பேஸ் பண்ணி கூட நமக்கு பேசிக் ஸ்ட்ரென்த் கொடுக்க வாய்ப்பு இருக்குது அப்படின்ட்டு சொல்கிறாங்க. ஸோ ஸ்ட்ரக்சர் பேசிசிட்டி ரிலேஷன்ஷிப் ஆஃப் amines. The basicity of amines is related to the structure. Basic character of an amine depends upon the ease of formation of the cation by accepting a proton. அதாவது ஒரு அமைன் வந்து எப்படி ஃபார்ம் ஆகும், பேசிக்கலி ஒரு பேஸ் அப்படின்றது எப்படி ஃபார்ம் ஆகும் அப்படின்னா by accepting an ease of formation of cation by accepting a proton from the acid. So accepting a proton from acid, for that it has to have a structure such that it has the ability to accept. So that's more important. The more stable the cation, the relative to the amine, more basic is the amine. Okay, so we will have to check the cation stability for checking the basicity. That's all about it. And if the structure gives if the structure helps for that, then it's well and good. If not, it is not that basic. So alkanamine versus ammonia. Let us consider the reaction of alkanamine and ammonia with a proton to compare their basicity. Let's say I have an alkanamine and I have ammonia. So in the particular reaction, both the nitrogen atoms have an unshared pair of electron which can accept a pair proton, and it will obtain a positive charge. In case of an alkylamine, it will be okay, fine. Due to the electron releasing nature of alkyl group, the alkyl group, it pushes electron towards the nitrogen, thus makes the unshared electron pair more available for sharing with the proton of the acid. Moreover, the substituted ammonium ion formed from the amine gets destabilized due to the dispersal of positive charge by the plus A effect. Stabilized by the plus A effect of the alkyl group. Hence, alkyl amines are stronger bases than ammonia. Basically, they are trying to emphasize the fact that alkyl amines are stronger bases than ammonia due to the fact of plus I effect. Thus, the basic nature of aliphatic amines should increase with the increase in the number of alkyl groups. So, more the number of alkyl groups, more will be the basic nature. This trend is followed in the gaseous phase. So, gaseous phase, this is the trend. So, the order of basicity of amines in the gaseous phase follows. So, we will have to remember the order of the phase follows the expected order. So we will have tertiary amine, secondary amine, primary amine, and then ammonia, which means that tertiary amine, which has a lot of alkyl groups, will be more basic. The trend is not integral in aqueous state. In the aqueous phase, the substituted ammonium cations get destabilized not only by electron releasing effect but also by solvation with water molecules. So it is not regular in aqueous. In aqueous medium, we will have something called as solvation with water molecules. Greater the size, lesser will be the solvation, less stabilized is the ion. So if we have greater size, then obviously the solvation will be lesser. So the stability order follows this. Primary will have more stable than secondary than tertiary, So that's the stability order, which means that greater is the stability of the substituted ammonium cation, stronger should be the corresponding amine, which means that the order of basicity of aliphatic amines. So from solvation effect, taking into the effect of solvation, we will say primary is greater than secondary greater than tertiary, rather than saying tertiary prime secondary primary, which is opposite to the inductive based effect. Secondly, when the alkyl group is small, like methyl, there is no steric hindrance to hydrogen bonding. In case the alkyl group is bigger than ammonia, methyl, there will be steric hindrance. So we talked about solvation effect. We previously talked about inductive effect. Now we are talking about solvation effect. Steric hindrance effect. Steric hindrance effect. If methyl group is present, it's not a problem. But if it is a bigger alkyl group than methyl, then it's going to be a problem. Be steric hindrance hydrogen bonding. Therefore, the change of nature of alkyl group, example from methyl to ethyl, results in the change of order of basic strength. So we'll have to mark this out. Smaller the alkyl group, no steric hindrance to hydrogen bonding, so more will be the stability. So whenever we are changing it from methyl to ethyl, it results in change of order of basic strength. Thus there is a subtle interplay of the inductive effect, solvation effect, and steric hindrance in the alkyl group for showing the basicity. This is the basic strength. So order of basic strength in case of methyl substituted amines and ethyl substituted amines are as follows. So if I have ethyl substituted amines, basically I will have secondary greater than tertiary greater than primary greater than obviously greater than ammonia. In case of methyl, it will follow primary, secondary, tertiary. அவ்வளோதான். Secondary, primary. So primary and tertiary are having interplay, whereas secondary will always be the higher stable guy in case of an aqueous solution. Great. So now we talked about alkylamine versus ammonia. Now we're entering into arylamine versus ammonia. So pKb values of aniline is quite high. Why is it so? It is pKb value is high means the basicity is low. It is because in aniline or other arylamines, the NH2 group is attached directly to the benzene ring, which results in the unshared pair of electron on nitrogen to be in conjugation with the benzene ring, making it less available for protonation. So basically, the reason for having a higher pKb value is due to the fact that there is an unshared pair of electron in the nitrogen atom in conjugation with the benzene ring, which makes it less available for protonation. So if you write different resonance structures of aniline, you will find that the aniline is a resonance hybrid of the following 5 structures. So if I am drawing an aniline, so basically I have 5 resonance structures in which 2 structures will be similar. This guy and this guy will be the similar structures, and this will be an intermediate structure. On the other hand, anilinium ion obtained by accepting a proton can have only 2 resonating structures, Kekulé structures. So anilinium ion, which is obtaining a proton, will have only 2 structures, that is this. So obviously, if it is having lesser number of resonance structures in presence of more protonation, which means that it is going to be less stable. We know that the greater the number of resonance structures, greater is the stability. Thus you can infer that aniline 5 resonating structures is more stable than anilinium ion. So we are concluding from here that aniline with a 5 resonating structure will always be more stable than anilinium ion with a 2 resonating structure. Hence the proton acceptability or the basic nature of aniline other aromatic amines would be less than that of ammonia. In case of substituted aniline, it would be less than, in case of substituted aniline, it is observed that the electron releasing groups like methoxy or methyl increase the basic strength, whereas electron withdrawing groups. So substituted aniline observed electron releasing groups increases the basic strength. Electron withdrawing group will obviously decrease the basic strength. That is fine. So that's the basicity. So we'll have to arrange the following in decreasing order of the basic strength. So this is an arylamine ammonia. So கண்டிப்பா அம்மோனியாக்கு பின்னாடி தான் இதை போடணும். So this will be 4 3 and this is 2 1 and since we are talking in terms of okay fine, secondary will always be greater than primary, yeah. So கரெக்டாக தான் எழுதியிருப்போம். Okay, yeah. Next we are entering into alkylation with alkyl halides. We'll have to refer for class unit 6. So amines on reaction with alkyl halides, just now we saw there's a kind of substitution where the CX bond is cleaved, leading to the formation, so that's fine. Next one, the acylation. Aliphatic and aromatic primary and secondary amines react with acid chlorides. Yeah. How much pages? Okay, we have 4 more pages. Yeah, let's try completing it. Acylation. Aliphatic and aromatic primary and secondary amines react with acid chlorides. Acid chlorides means basically RC double bond OCl. So upon reaction with the primary or secondary amine, let's just write it as this way. So react with anhydrates and esters by nucleophilic. Anhydrate is the same RC double bond OC double bond O R dash, or esters is RC double bond O R dash. These are the acid derivative guys. So acid derivative guys will give nucleophilic substitution reactions. Nucleophilic substitution implies that I'm going to substitute a nucleophile and the other guy will be removed. The leaving group will be removed, and this reaction is known as an acylation. So acylation is going to be a nucleophilic substitution reaction, which, so you can consider this reaction as the replacement of hydrogen atom of NH2 or NH group by the acyl group. The products obtained by acylation reaction are known as amides. So basically we are going to replace the NH2, okay fine, hydrogen of the NH2 or NH by an acyl group. That's all we are going to do, and this is what we will obtain, and this product obtained are called amides. Okay, acyl group. So this reaction is considered as a replacement. Okay fine. So basically the product we are obtaining is going to be called as an amide. The reaction is carried out in the presence of a base stronger than amine like pyridine, which removes HCl so formed and shifts the equilibrium to the right hand side. So in the reaction அப்படின்றது it is carried out in presence of base stronger than amine. Why is it so? Like pyridine, which removes the HCl formed and shifts the equilibrium to right hand. Okay, so basically there will be HCl formation because there will be cleavage of chlorine and H plus from the ammonia, and HCl will be formed eventually. To cancel out its effects, we will have to have another base which will neutralize the HCl, so for which we will have to use a stronger base than amine, the given amine, so like pyridine, which removes the HCl. Okay, stronger base பயன்படுத்துறோம் because it will move the shift the equilibrium to the right hand side by removing the HCl formed during the reaction of nucleophilic substitution between the acyl group and the amine. Yeah, that's it. So we'll use a base stronger than amine like pyridine. So let's say I have an ethanamine. Okay, I'm having a acid chloride upon reaction with ethanamine gives a nucleophilic substitution reaction, because it's not a elimination, because chlorine and carbon chlorine bonding is polarized ஆயிருந்த carbon will have a partial positive charge and chlorine will have a partial negative charge. So there's going to be substitution occurring, which means that the chlorine, first of all, oxygen's double bond is removed and oxygen carries a negative charge, so it is going to be a stable transition state. The transition state going to be stable in presence of base. So then H plus is removed. Okay fine. Since nitrogen is carrying a positive charge, being an electronegative element, it cannot bear that, which means H plus can be removed easily, and it can be removed easily due to the fact that a base is present, which means it can neutralize this effect of base or whatever. So and also eventually the oxygen carrying a negative bond, there is always a tendency for formation of C double bond O. In this particular case, C double bond O formation is favored, which means that a chlorine which is a good leaving group will leading to the formation of Cl minus, and already H plus is present, which leads to the formation of HCl, which is neutralized by the base. So that's all is gonna occur. That's the reaction. So that's going to occur. So let's say I have acid chlorine, that's going to be the reaction. Let's say I have ethanoic anhydride. Okay, phenylethanamide or acetanilide. Amines also react with benzoyl chloride. Amines also react with benzoyl chloride. This reaction is known as benzylation. So when it is reacting with benzoyl chloride, it is known as benzylation. CH3NH2, which is called as methanamide. Benzoyl chloride gives N-methyl benzamide. Okay, what do you think is the product of the reaction of amines with carboxylic acids? They form salts with ammonia amines at room temperature. Simple. Amines are going to act as Lewis base, and which means that it will react with an acid to give us salt. That's it. That's all gonna happen. So that's the reaction of acylation. Basically, acylation is an replacement of hydrogen group of amine with an acyl group. Okay, that's it. Great. I think it's the product of reaction of amines. So yeah, next we are entering into carbylamine reaction. Carbylamine reaction, aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide forms isocyanates or carbylamines, which are foul smelling substances. Okay, so basically a primary amine upon reaction with the chloroform in ethanolic potassium chloride, potassium hydroxide and heat forms an isocyanate. An isocyanate being foul smelling shows that there is a presence of a primary amine. So chloroform in presence of potassium chloride, potassium hydroxide in heat giving a foul smell implies there is a aliphatic primary amine or aromatic primary amine. So this is known as carbylamine reaction, not given by carbylamine reaction or isocyanate test, which is not given by tertiary or secondary amine, and is used as a test for primary amines. Okay, so we can write it as a test for primary amines. Yeah. Next we are entering into reaction with nitrous acid. Nitrous acid is HNO2. Three classes of amines react differently with nitrous acid. Basically we have primary, secondary and tertiary amines. Each of them will react differently. I think that's how they are talking about this, but we are only given with primary amine reactions over here. That's fine. It's present in C2 from a mineral acid and sodium nitrite. I think I will be able to cover this up till sulfonation, and I'm having certain in-text questions as well. Yeah, we can push it up. So first, primary aliphatic amines react with nitrous acid to form aliphatic diazonium salts. Diazonium salt means basically N double bond N formation. So basically HNO2 with RNH2 forms Rn2 plus Cl minus. So that's the reaction. It is unstable gas quantitatively and alcohols. Okay. Quantitative evaluation of nitrogen is used in estimation of amino acids and proteins. Okay, so basically reaction of primary amines with nitrous acid leads to a formation of a diazonium salt, which is unstable upon reaction. Upon hydrolysis leads to alcohol and hydrochloric acid and nitrogen gas, and the liberated nitrogen gas will be used in the quantitative like estimation of amino acids. Okay, fine. Aromatic amines react with nitrous acids at low temperatures. So this is going to be a low temperature reaction at low temperatures to form diazonium salts, a very important class of compounds used for synthesis of variety of aromatic compounds discussed in section 9.7. Okay, so yeah. Okay, secondary and tertiary amine reaction with diazonium, NaNO2 nitrous acid is not given. That's fine. Reaction with aryl sulfonyl chloride. Benzene sulfonyl chloride, which is also known as Hinsberg reagent, reacts with primary and secondary amines to form sulfonamides. Okay, fine. Also known as Hinsberg reagent. Hinsberg reagent is basically benzene sulfonyl chloride. Benzene sulfonyl chloride C6H5SO2Cl. Hinsberg reagent reacts with primary and secondary amines to form sulfonamides. So primary and secondary amines upon reaction with benzene sulfonyl chloride leads to the formation of sulfonamides. So the reaction of benzene sulfonyl chloride with primary amine yields N-ethyl benzene sulfonyl amide. இருப்பா ஒரு நிமிஷம். So I'm having benzene sulfonyl chloride, which is the Hinsberg reagent upon reaction with the primary. So I'm having a primary amine over here. Basically it leads to the formation of the HCl chachar, and it forms N-ethyl benzene sulfonamide. Okay, the hydrogen attached to nitrogen sulfonamide is strongly acidic due to the presence of a strong electron withdrawing sulfonyl group. Hence it is soluble in alkali. So it's acidic in nature, so it means it is soluble in alkali. Soluble, yeah, they have written it acidic hydrogen. So in reaction with secondary amine, it doesn't have any hydrogen, which means it is not soluble in alkali. It does not contain hydrogen. Yeah, that's all about it. That's it. Arre yaar, simple question yaar. Tertiary amount does not react because it does not have any hydrogen for formation of HCl, benzene sulfonyl chloride. This property of amines reacting with benzene sulfonyl chloride in different manners used for the distinction of primary, secondary and tertiary amines, used for the separation of mixture of amines. However, these days benzene sulfonyl chloride is replaced by para-toluene sulfonyl chloride, that is tosyl chloride. That's what we say it as para-toluene, but that's fine actually. Primary amine soluble in alkali upon reaction with benzene sulfonyl chloride. So Hinsberg reagent, that test is used for the differentiation reaction with aryl sulfonyl chloride. Yeah, fine. Great. Electrophilic substitution. You have read earlier that aniline is a resonance hybrid of 5 structures. Where do you find the maximum electron density in these structures? Ortho and para positions to the amine group become centers of high electron density. Thus NH2 group is ortho and para directing and a powerful activating group. So we know that aniline is a resonance hybrid of 5 structure. So where will we have the electron density maximum? We'll have it on ortho and para positions to the NH2 and becomes the centers of high electron, which means the NH2 group is a para and ortho directing group and a powerful activating group. Yeah, so basically bromination in aniline. So this is what we call as the electrophilic substitution, where we'll have Br plus as the electrophile, which will be substituted, okay, at room temperature to give a white precipitate of 2,4,6, and room temperature it forms tribromoaniline. The main problem encountered during electrophilic substitution reactions of aromatic amines is that of their very high reactivity. So basically they have very high reactivity. Okay, substitution tends to occur at ortho and para positions. If we have to prepare monosubstituted aniline derivative, how can the activating effect of NH2 be controlled? This can be done by protecting the NH2 by acetylation followed by hydrolysis of the substituted amide to the substituted amine. Oh, fine. So basically what we are doing is that NH2 is a very powerful activating group, which means that the reactivity is going to be higher. To prevent that type of reactivity, we will basically acetylate. That means we'll do acetylation in presence of pyridine, and then we'll do the bromination, which will lead to the formation of a major product. That will be para derivative will be a major product, and then again we upon hydrolysis acetic anhydride. Okay, then carrying out the desired substitution followed by hydrolysis on the substitution leads to the, okay, so we'll basically create an amide by reaction with acetic anhydride. Any anhydride is fine, and upon reaction with the bromine, bromination reaction will have to occur in presence of acidic medium, it seems. I'm not sure because they are using acetic acid, and then upon hydrolysis I'm obtaining the required. The lone pair of electrons on nitrogen of acetic anhydride interacts with oxygen atom due to the resonance as shown below. So the lone pair of electrons on nitrogen of acetanilide interacts with oxygen atom due to the resonance. Okay, fine. So what you are trying to imply? Since the lone pair of electrons on nitrogen is less available for donation to benzene ring. Oh, so that's why the activating effect is becoming lesser in case of NHC double bond CH3, that's amide group presence. Next I have nitration. Direct nitration finally leads terry oxidation products in addition to the nitro derivatives. Okay, so we'll have nitro derivatives as well. So moreover, in the strong acidic medium, aniline is protonated to form anilinium ion, which is metadirecting. That is why besides the ortho and para derivatives, significant amount of meta derivative also obtained. That is 47% of meta derivatives obtained. Only 2% of ortho derivatives obtained, because due to the fact that it's having more steric hindrance. However, by protecting the NH2 group by acetylation reaction with acetic anhydride nitration reaction can be controlled, the nitro derivative can be obtained as a major product. So basically, nitration can be done in presence of nitrous acid and sulfuric acid at very low temperature, leading to the formation of orthopara and meta. The meta product is going to be significant because there will be a formation of an anilinium ion, which is due to the protonation in acidic medium. As we are having acidic medium, there will be protonation as well, which means that it will be leading to a formation of meta directing group. So that's going to be significant. Okay, fine. And then we have sulfonation reaction. Aniline reacts with concentrated sulfuric acid to form anilinium hydrogen sulfate, which on heating with sulfuric acid. So first of all, we'll have concentrated sulfuric acid to form anilinium hydrogen sulfate. Anilinium hydrogen sulfate, which on heating with sulfuric acid at 453 to 473 Kelvin produces para-aminobenzene sulfonic acid, commonly known as sulfonilic acid. Okay, wait a minute. So it reacts with sulfuric acid, forms anilinium hydrogen sulfate. On heating, produces para-aminobenzene sulfonic acid. So NH3 plus HSO4 minus will have NH2, and HSO4 will be, SO3H will be in the para position, which will lead to the formation of sulfonylic acid. That's actually Zwitter ion formation. Aniline does not undergo Friedel-Crafts reaction, that is alkylation acylation, due to the salt formation with aluminium chloride, Lewis acid, which is used as a catalyst. Friedel-Crafts reaction we will have aluminium chloride as the catalyst. Ana aluminium chloride will react with aniline, leading to the formation of a salt. Ena, the hydrogen bonded with nitrogen will be acidic, and aluminium chloride is a Lewis base, leads to the formation of an acid-base reaction. So there is no Friedel-Crafts reaction. Aniline does not undergo Friedel-Crafts reaction. Okay, fine. Due to the salt formation with aluminum chloride, the Lewis acid, which is used as a catalyst, due to this nitrogen of aniline acquires positive charge and hence acts as a strong deactivating group for further reaction. அதாவது இந்த பர்டிகுலர் ரியாக்ஷன் காரணமாக nitrogen of aniline acquires positive and hence acts as a strong deactivating group. Okay, so Zwitter ion is the separation of charges between. Okay, fine. So we have certain in-text questions as well. Before that, we will check for diazonium salts. I think it is also important to cover. We have just 4 pages, but let's just do the questions. Arrange the following in the increasing order of their basic strength. Ammonia, Sonia, aliphatic will be greater than ammonia. Secondary greater than primary. So this is gonna be 2, 1. Then have CH2 group. I think this is going to be 3, 4, and 5. I'm not sure. C2H5NH2, C2H5NS, C2H5N, C6H5NH2. Tertiary greater than, secondary greater than, primary greater than 3, 2, 1, 4. And then we have CH3NH2, CH3 taken twice NH, C6H5. Okay. Complete the following acid-base reactions and name the product formed. So acid-base reaction, which means that the hydrogen over here and the chlorine over here. Wait a minute. No, it doesn't work that way. Basically, this is going to be the base and this is going to be the acid. So it's going to NH2. Cl will be removed, and I think wait a minute, what's going to happen? Amine is going to act as a nucleophile. It's going to cleave the HCl bond. Chlorine will act Okay, fine. C2H5 taken thrice and nitrogen. Something wrong. Wait a minute. NH2 is going to act as okay base. என்ன நடக்க போகுது? C2H5 taken thrice. Oh damn. It's going to be acid base reaction. I'm having the base over here. Base can donate a pair of electrons and it can accept a proton. Okay, it's going to form a diazonium salt, right? I think this should be the reaction. Yeah, it's perfect. Write the reactions of the final alkylation product of aniline with excess of methyl iodide in the presence of sodium carbonate solution. So I'm gonna alkylate methyl iodide, sodium carbonate solution, excess, which means it's gonna form N, N dimethyl methanamine. I think that's the final alkylation product. Benzoyl chloride. Okay, reaction of aniline with benzoyl chloride and write the name of the product obtained. Benzoyl chloride means it's going to be C double bond O Cl. So which means we'll have to remove H from here, Cl from there. So wait a minute. I think that's how the reaction works. Wait a minute. So let's say I have this aniline NH2 plus C double bond O Cl. So one H is removed. I think they're asking the name of the product as well. So it's secondary amine, and we'll take this as the product, and it's gonna be amide as well. No, yes, no, yes. Sonia. Okay, we have something called as diazonium salts. So the diazonium salts have the general formula Rn2 plus X minus diazo. Azo means 2, nitrogen, and di means 2, which means there are 2 nitrogens, where R stands for an aryl group, X minus stands for any of the halogens or any type of negative ions like Cl minus, Br minus, Bf4 minus, HSO4 minus. They are named by suffixing diazonium to the name of the parent hydrocarbon. ஸோ எப்படி நேம் பண்ணுறோம் அப்படின்னா சஃபிக்ஸிங் டையோசோனியம், அதாவது பேரன் ஹைட்ரோகார்பனோட டையோசோனியம் அப்படின்ற நேம் வந்து ஆட் பண்ணிக்குவாங்க, ஃப்ரம் விச் தேர் ஃபார்ம் followed by the name of the anion such as chloride, hydrogen sulfate, etc. So we will have the respective halon names. Like if I am having a chloride, it's going to be chloride, bromine which means bromide, HSO4 which means it's going to be hydrogen sulfate, something like that. The N2 plus group is called diazonium group. For example, C6H5 N2 plus Cl minus. It's going to be benzene diazonium chloride. That's it. And then it's going to be benzene diazonium hydrogen sulfate. That's it. That's how we are going to name it. Primary aliphatic amines form highly unstable alkyl diazonium salts. So primary aliphatic amines form highly unstable diazonium salts. The primary aromatic amines form arene diazonium salts, which are stable for a short time in solution at low temperatures. Stability of arene diazonium ion is explained due to the presence of resonance. So aliphatic, there's not going to be that stable, which means there's no resonance, something like that. Whereas primary aromatic amines form arene diazonium salts, which are stable for a short time in solution at low temperatures. Okay, fine. So we have certain preparation reactions, methods of preparation. Benzene diazonium chloride is prepared by the reaction of aniline with nitrous acid NaNO2 plus HCl at 273 to 278 Kelvin, which is at very low temperature, 0 to 5 Kelvin, 5 degrees Celsius. Nitrous acid is produced in the reaction mixture by the reaction of sodium nitrite and hydrochloric acid. So to create a nitrous acid, we'll have to just react sodium nitrate and hydrochloric acid. The conversion of primary aromatic amines into diazonium salts is known as the diazotization reaction. So basically we are converting it into diazonium salt, which means this is the diazotization reaction. Due to its instability, the diazonium salt is not generally stored and is used immediately after its preparation. ஸோ அதோட இன்ஸ்டெபிலிட்டியின் காரணமாக டைஅசோனியம் சால்ட்டுன்றதை ஸ்டோர் பண்ண மாட்டோம், ப்ரிப்பரேஷனுக்கு உடனே வந்து என்னென்ன ப்ராடக்ட் தேவையோ அந்த மாதிரி கன்வெர்ட் பண்ணிக்குவோம். ஸோ சில ஃபிசிக்கல் ப்ராப்பர்ட்டி இட்ஸ் கோயிங் டு பி a colorless crystalline solid. So this is important. Physical properties are really important for amines chapter. It is readily soluble in water and is stable in cold but reacts with water when warmed. So it is readily soluble in water, in cold, whereas when I am heating it up, just reacts with water when it is warmed. It decomposes easily in the dry state. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. Benzene diazonium fluoroborate is water insoluble and stable at room temperature. Okay, fine. Okay, fine. So the this is the physical property. Physical property is that it is a colorless crystalline solid, reacts with water when it is warm, and it decomposes easily in dry state. And benzene diazonium fluoroborate BF4 minus is water insoluble. Great. Now we are entering into certain chemical reactions. So the reactions of diazonium salt can be broadly divided into two categories, namely A, reactions involving displacement of nitrogen, and B, reactions involving retention of diazo group. So there are certain reactions in which we are going to displace the nitrogen, which are the famous reaction, because diazonium group is a very good living group. It is substituted by certain other groups like chlorine, bromine, hydrogen, cyanide, hydroxyl, which displace the nitrogen from the aromatic ring. The nitrogen formed escapes from the reaction mixture as a gas. So basically the replacement of halide or cyanide ion, the Cl minus, Br minus, Cn minus nucleophiles can be easily introduced in the benzene ring. So let's say I have a benzene ring. Here N2 minus, N2 plus, X minus. So if I have to substitute chlorine, which means I will have to use CuCl2 in presence of HCl, which can readily create a Cl minus ion, and this will be substituted ArCl plus nitrogen gas will be liberated. Similarly ArN2 plus X minus in presence of CuBr2 in HBr reaction will give me ArBr with dinitrogen liberation. So that's how the reaction is going to work, right? So this is what we call as the Sandmeyer reaction. The Sandmeyer reaction is the introduction, okay, the Cl minus Br minus nucleophile can introduce benzene in the presence of Cu1 cation, known as the Sandmeyer reaction. Alternatively, chlorine or bromine can also be introduced in the benzene ring by treating the diazonium salt solution with corresponding halogen acid. With corresponding halogen acid in the presence of copper powder. So this is called Gattermann reaction. Gattermann reaction is basically if I have an aryl group, just by using aryl halogen acid HCl, HBr, HI in presence of copper powder itself can release the N2 plus X minus ion, leads to the formation of chlorination or bromination. This is what we call as the Gattermann reaction. So we have learned two important reactions over here. One is the Gattermann reaction, which is the usage of the acid chloride, halogen acids itself, replacement of halide ion. There is another reaction called as the Sandmeyer reaction, which uses Cu1 plus cation, leading to the release of required anion to be substituted in the aryl group. So next, the yield in Sandmeyer reaction is found to be better than Gattermann reaction. So the முக்கியமான பாயிண்ட் வந்துட்டு இதுதான், Sandmeyer reactionல இருக்க yield will be better than that of Gattermann reaction. I don't know why. Let's see. Next, replacement of iodide. Iodide ion we will not simply we cannot replace it, for which we will have to introduce a very strong oxidizing agent. Iodine is not easily introduced into the benzene ring directly, but when the diazonium salt solution is treated with potassium iodide, iodobenzene is formed. So easily it is not formed, but reaction with potassium iodide, it leads to the formation of an iodobenzene. Replacement of fluoride ions, we have certain replacement reactions of fluoride ion. We have iodide ion, we have fluoride ion. When arene diazonium chloride is treated with fluoroboric acid is basically HBF4, arene diazonium fluoroborate, diazonium fluoroborate N2 plus BF4 minus precipitated, which on heating decomposes and forms ARF. So basically this is how we are obtaining fluoride ion substituted on benzene. Next, H, replacement by H. For H, we will basically use something called as H3PO2 and water. That is a mild reducing agent. Hypophosphorus acid, phosphenic acid, or ethanol reduce the diazonium salts to arenes, and themselves gets oxidized to phosphorus acids and ethanol. So basically I'm having arene diazonium chloride with phosphoric acid, hypophosphorus acid, alladu I can also use ethanol to obtain the benzene to be formed. So this is a preparation reaction for benzene from benzene diazonium salt. And replacement of hydroxyl group, for which we will have to use water can be used up to 283 Kelvin to get to obtain phenol. So reaction for obtaining phenol is over here, for benzene is also over here. So the phenol, a benzene can be obtained by using hypophosphorus acid or ethanol. Replacement of by NO2 group. Okay, we can also replacement by NO2 group. So we saw hydroxyl group, for which we used water. For NO2 group we use something called like HPF4. Okay, when diazonium fluorochloride is heated with aqueous medium of nitrite solution, NaNO2, NO2 minus, that is nitrite solution, it leads to the formation of, okay, in presence of copper, leads to the formation of diazonium group replacing by NO2 group. That's a nitrobenzene group. So these are certain important reactions in which we'll have like removal of N2 plus, and the other important reaction is the retention of diazo group by coupling reactions. The azo group tended to have an extended conjugated system having both aromatic rings joined through the N double bond N bond. அதாவது நம்ம அசோ ப்ராடக்ட்ஸ் அப்படின்றதுல வந்துட்டு நம்ம என்னென்னா என் டபுள் பாண்ட் என் பாண்ட் என்பது இந்த ரிங்கோட அட்டாச் ஆகியிருக்கும் அப்படின்னு சொல்கிறாங்க. தீஸ் காம்பவுண்ட்ஸ் ஆர் ஆஃபன் கலர்டு. ஸோ இந்த பர்டிகுலர் கேஸில் வி ஆர் ஹேவிங் தீஸ் காம்பவுண்ட்ஸ் as colored and these are used as dyes. Benzene diazonium chloride reacts with phenol. So we are having benzene diazonium chloride. Upon reaction with phenol, it is at its para position is coupled with the diazonium salt to form para hydroxybenzene. ஸோ அதாவது என்ன சொல்கிறாங்க, பாரா பொசிஷனில் பேசிக்கலி NHCl அப்படின்ற மாதிரி ரிமூவல் நடந்து வேறு obtaining para hydroxy azobenzene அப்படின்ற மாதிரி சொல்கிறாங்க, which is going to be orange dye. This type of reaction is known as coupling. Similarly, the reaction of diazonium salt with aniline order we are obtaining a yellow dye. This is the same reaction which leads to the formation of para amino azobenzene. Initially நமக்கு para hydroxy azobenzene வந்துச்சு, and இதில் வந்து para amino azobenzene வருது. This is an example of an electrophilic substitution reaction where we are substituting the hydrogen with the diazonium chloride, diazonium benzene, azobenzene, whatever you name it is. So the hydroxy azobenzene is going to give me a orange dye, whereas amino benzene azobenzene is going to give me a yellow dye. So these are two important parts to be noted: orange dye and yellow dye, given by hydroxy and amino groups respectively. And there is an importance of diazonium salt in synthesis of aromatic compounds. Let's see what is it. So from the above reactions, it is clear that the diazonium salts are very good intermediates for the introduction of fluorine, chlorine, bromine, iodine, cyanide, hydroxyl, nitro groups into the aromatic ring. Aryl fluids and iodides cannot be prepared by direct halogenation. The cyano group cannot be introduced by nucleophilic substitution reaction of chlorine in chlorobenzene, but cyanobenzene can be easily obtained from diazonium salt. அதாவது குளோரோபென்சீன்லேருந்து சைனோபென்சீன் வந்து கொண்டு வரது கஷ்டம், ஆனால் டயோசனியம் சால்ட்லேருந்து we can easily obtain cyanobenzene அப்படின்னு சொல்கிறாங்க. Thus, the replacement of diazonium group by other groups is helpful in preparing those obtained aromatic compounds which cannot be prepared by direct substitution in benzene. So, direct substitution ஆகாத சில compoundsல வந்துட்டு we can use this diazonium as a intermediate to obtain the required amount of substituted product. Okay, fine. How will you convert 4-nitrotoluene to 2-bromobenzoic acid? Super. So 4-nitrotoluene, I think first bromination பண்ணுறது important. ஏன்னா CH3ன்றது ஆர்த்தோ para directing and NO2 is also meta directing. அப்போ NH2 கன்வெர்ட் பண்ணதுக்கப்புறமா பண்ண ட்ரை பண்ணோம் அப்படின்னா there will be a mismatch occurring and obviously it's going to be meta directing வந்துடும். ஸோ 3 பொசிஷனில் வந்துடும். ஸோ அப்போ கண்டிப்பாக ஃபஸ்ட்டு ப்ரோமினேஷன் பண்ணணும். ப்ரோமினேஷனுக்கு வந்து வில் ஹாவ் எலக்ட்ரோஃபிலிக் சப்ஸ்டிடியூஷன் ஆஃப் ப்ரோமின் இன் பென்சீன். அது எப்படின்னா வில் டேரக்ட்லி ரியாக்ட் வித் Br2 in presence of water or something like that. ஸோ வில் obtain a ஆர்த்தோ ப்ராடக்ட், ஆர்த்தோ டெரிவேட்டிவ், அதில் ப்ரோமின் வந்துடும். நெக்ஸ்ட்டு SnHCl வந்து ரிடியூசிங் ஏஜென்ட்டை பயன்படுத்தும் போது NH2 obtain ஆகும். அடுத்து NaNO2HCl nitrous acid யூஸ் பண்ணுறது மூலிமா we are obtaining diazonium salt. Diazonium saltோட டைரெக்டாக just hydrogen obtain ஆகணும், which means that we will have to use hypophosphoric acid or phosphinic acid, both are same. I'm obtaining CH3B with Br in the ortho position. இப்போ oxidizing agent with like நல்ல strong oxidizing agent யூஸ் பண்ணோன்னா கண்டிப்பாக it is oxidized into carboxylic acid. இதுதான் வந்துட்டு reaction. 3-methyl aniline into 3-nitrotoluene. So aniline with 3-nitrotoluene. Simple. Basically we'll have to just convert okay, first நம்ம வந்துட்டு NH2 ஓட NaNO2 plus HCl at 273 to 8 Kelvin யூஸ் பண்ணும்போது I am obtaining diazonium salt. Upon reaction with HbF4 I am obtaining N2 plus BF4 minus, and upon using nitration reactions like HNO3 H2SO4 something like that I am obtaining 3-nitrotoluene. Next aniline into 1,3,5 tribromobenzene. 1,3,5 tribromobenzene. ஃபஸ்ட்டு வந்துட்டு அனிலீனில் bromine வாட்டர் யூஸ் பண்ணுவோம். bromine வாட்டர் யூஸ் பண்ணுறது மூலயமா டேரெக்டாக 2,4,6 வந்துட்டு we are obtaining bromine. Next anilinoda we will have reaction with NaNO2 plus HCl, will lead to the formation of diazonium chloride, and upon using phosphonic acid I am obtaining 1,3,5 tribromobenzene. So let's have a quick recap, and I think we are having 14 questions over here as well. Okay, 14 questions are here. Let's just have a quick recap, starting from amines from the first. So basically amines are essential substituents of medicines and fibers. So we have proteins, vitamins. Natural sources of amines is that we have proteins, vitamins, alkaloids, and hormones. And synthetics are basically dye, obviously that should be remembered, and there are certain drugs as well. We have certain biologically active compounds like adrenaline and ephedrine, which has secondary amino group, and novocaine, which is a synthetic amino compound, which is an anesthetic. Anesthetic is something related to chemistry in everyday life, which I am not entering into now. In dentistry, and Benadryl is a it's a tertiary amino group. It is an antihistaminic group, and quaternary ammonium salts are used as surfactants. We are talking about amines. Amines are basically the amino acids. Ammonia group, if I am replacing 1, 2 or all the 3 hydrogens with certain alkyl aryl groups, it's going to lead to the formation of an amine. So there are certain structure. The structure is going to be sp3 hybridized due to the fact that it has 3 bond pairs and 1 lone pair, and it's going to give me a pyramidal structure. Because the lone pair is basically, it's not considered as a type of structure actually in physical significance. So and the CNE bond, due to the presence of unshared there's a lone pair bond pair repulsion, which means the actual angle of 109.5 degree is reduced. It can be something less than 109.5 degree, and then we have certain classifications as primary, secondary, and tertiary, and then we have certain nomenclature for aliphatic amines. Common name nomenclature is that it is just it was written as alkylamine, whereas in IUPAC we write it as alkanamine. And then for aryl we have we will remove the suffix e of the arene and replace it by amine. That's it. That's all about it. And that's IUPAC. I'm not getting more into it. Then we have certain preparation. First we'll reduce the nitro compounds. Nitro compounds reduction can lead to the formation of amines, and the best best reagent that can be used is the Fe plus HCl, because it leads to the formation of FeCl2, which will further upon hydrolysis gives HCl, and further a very small amount of HCl is enough for this reaction to initiate. Next we have ammonolysis. Ammonolysis is a nucleophilic substitution reaction where we'll have a cleavage of CX bond. CX bond is polarized, which means substitution of CX bond leads to the leaving group of X, and something like that will lead to the formation of a primary amine. And more the amount of halogen, more the amount of alkyl halide, more will be greater will be the formation of quaternary ammonium salt. Else the excess of ammonia will lead to the formation of a primary amine. That will be a major product. And then we have certain disadvantage, that is we cannot the major product, there will be mixture of products formed. The order of reactivity will also be I minus will get greater than Br minus greater than Cl minus. And then we have reduction of nitriles. Nitriles can be reduced in presence of LaH or H2 in presence of nickel. Reduction of amines. Reduction of amines can be done by LaH. LaH will basically remove the amide C double bond group and convert it into CH2 NH2. And Gabriel-Thielemann synthesis of primary amines and aromatic primary amines can be formed because the substitution reaction of alkyl halides cannot be done with aromatic primary amines. And we have Hofmann-Bromamide degradation, where we will remove the C double bond O group and just have this is going to be step down reaction, and we had a step up reaction of reduction of nitriles. Reduction of nitriles is a step up reaction as well. And then this is the preparation reactions. And then we have certain physical properties. The lower amines have a fishy order, up to 3 or 4 carbons it will be a liquid, and then from there on it will be a solid. And the solubility will be, it will be soluble in water, it will be soluble in organic solvents, but it is less soluble than alcohol. And the boiling points will be highest for primary, followed by secondary, and then tertiary. And then we'll have okay, next chemical reactivity. First we will target the basic character. Basic character will be in such a way that in gaseous phase tertiary will be greater than basic character of tertiary greater than primary, secondary greater than primary, greater than ammonia. And aryl amines will have the lesser basic character than ammonia, but in case of solvated effect, due to solvation effect, we will have something like secondary greater than tertiary greater than primary. And sorry, yeah, I think that's how it works. Okay, it depends upon what the substituted alkyl group is. If it is a methyl group, it's going to be different order. The order is going to be secondary, primary, and then tertiary. If it is ethyl group, I think I'm saying the wrong way. It's going to be secondary, tertiary, primary. And if it is going to be an ethyl or something like a carbon alkyl group with more number of carbons, it's going to be secondary, primary, and tertiary. So that's how it's going to work. So yeah, so that's all about these pages. Yeah, we are done here. Alkylation reaction, simple. It's going to be the cleavage of CX bond, and yeah, that's what it's going to happen. Acylation reaction will basically use a stronger base as a medium, due to the fact that there will be a formation of halogen acid, which will be neutralized by the base. So yeah, the reaction can occur with either with acid chloride or acid anhydride or ester or something. Any acid derivatives is acylation is fine. And there is something called as benzoylation reaction, where amines is reacting with the benzoyl chloride. And there is something called as carbylamine reaction, where the amines will be reacted with chloroform in presence of potassium hydroxide. And if it leads to a formation of foul smell, implies that there is a presence of NC isocyanate group. Isocyanate group will be formed only if there is a presence of primary amine. Next we have nitrous acid reactions. Nitrous acid reactions, we will obtain diazonium chloride, diazonium salts. Diazonium salts will readily, these are unstable, so they readily hydrolyze to form alcohols, nitrogen gas, and halogen acids respectively. So yeah, that's all about it. So sulfonyl chloride, Hinsberg reagent, primary amines forms salt that is soluble in alkali. Secondary amines also forms a salt which is not soluble. Tertiary amine does not even react with Hinsberg reagent. An electrophilic substitution reaction, we have ortho and para positions for aniline, ortho and para position. And to control it, we will have something called as acetylation, where we will use acetic anhydride to acetylate and reduce the positive inductive effect of the nitrogen by having resonance between the nitrogen and the oxygen present in conjugation. And then we'll do the required substitution, and finally we'll hydrolyze to obtain the required major product. And then we have nitration. For nitration we use HNO3 and H2SO4. And nitration, there will be a significant amount of meta product as well. That's important point over to be noted. And then we have sulfonation reaction will obtain okay, zwitterion ion formation is also obtained. Fine. We are entering into diazonium chloride. We saw the nomenclature, we saw the methods of preparation, we saw the physical property, the chemical reactions. The chemical reaction involves two types. One is of removal of nitrogen, and the another one is the presence of diazo compound. So both the reactions are available. So this, yeah, I think that's done. Then we have certain 14 questions to be covered. We'll do it after some time. We will. I think it can be done by yourself itself. So I'm ending the stream for the second session of the day.